Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white. When I've been said I've been technically speaking, said I've been technically speaking, China white.
All right, so welcome back to another lesson with the CCNA exam prep. We are still in section 3, which is IP connectivity here. Today's lesson is all about OSPF version 2. Okay, we're going to configure and verify single area, talk about what it is in whole, talk about the subcategories like neighbor adjacencies, point-to-point, router ID, etc. And then we'll do a little lab, a basic lab, and you guys can go ahead and take over, do that lab in your environment so you can understand the commands to configure OSPF. So let's get into it. The basic OSPF stands for open shortest path first, okay? V2 is version 2, okay? This open shortest path first protocol, routing protocol, it's not a Cisco thing, it's open source. So anybody can use it outside of Cisco, any vendor. Like I said, it's a routing protocol, a dynamic one. We call that a link state routing protocol. You guys should have saw that in our last lesson. We talked about different types of routing protocols. Version 2 just means that we have IPv4 because we have a version 3, not we, but OSPF has a version 3, which is IPv6. Today, we're just going to over V2, which is IPv4. This shortest path first, it's like an algorithm that I forgot his name, but he came out with this algorithm to basically determine the best path. Okay, and the best path is based off of cost and the bandwidth, cost bandwidth, synonymous when it comes to OSPF. Okay, another thing down here, well, I guess I can go down some more. ABR and ASBR, we kind of talked about that earlier. Last lesson. ABR is area border router. ASBR is autonomous system boundary. Okay, it's very important that you understand the difference. Okay, one is an autonomous system boundary router, right? And one is a border router. So the border router is basically a router that participates in OS. Let me kind of blow this up a little bit. That can participate in more than one area of OSPF. So OSPF automatically has one area, which is area 0. That's just the backbone area. Okay, see if I can put that up a little bit. Backbone area. And this backbone area, you can basically segment different networks just like you would with VLANs with OSPF. So you can have area 0, which is your backbone, that's your first area, and then you can create another area, area 1 or area 2. Now, one area, which we would call single area, that's usually for small, maybe even medium-sized companies that does not have like a wide range of segments or network segments. Multi-area, area 0, area 1, area 2. If we have more than one area, that's more for a larger or medium to large size companies. They'll have multiple OSPF areas. But small businesses, small companies usually only need one area, and that area is automatically area 0. You have to start off with that. So any router that we call ABR is a border router. It's a router that sits at the border of more than one area. As you can see right here, that's an ABR and that's an ABR. ASBR is autonomous system boundary route. Okay, so it operates in more than one autonomous system. Think of an autonomous system as two companies, right? Um, so this ASBR, as you can see, it's sitting in area 0, which would be, let's say it's ABC company, and at the another border of the internet is what it's depicting, but that's a whole nother protocol, routing protocol, which we talked about that. What's the internet's routing protocol, right? EGP, BGP, right? That is the protocol. So it's clearly operating in more than one protocol. One is OSPF, and the other one is in another autonomous system, which is the internet, which we can call BGP. Okay, so if you kind of went over that, you'll kind of understand a little bit more. But just understand that there's a single area and multi-area with OSPF, right? You always have to start off with area 0. You have ABR and ASBR. ABR participates in OSPF more than one area, sits at the border of more than one area. And ASBR is a router that sits in the border of two different autonomous systems. Okay, so you kind of got to look at it in that kind of realm. All right, let's talk about router IDs. So router ID is the IP address that basically will be the name of, or you could say will represent this this router, right? So each router in the network, the OSPF network, has a router ID, which is, you can think of it as their name. All right, because routers we know is going to have multiple interfaces configured on it. And how do we tell which one is the name of the router, the ID of the router? You know, so most of the time it's a loopback. Sometimes we could just create something regular, like regular interface. But most of the time we usually create a loopback. A loopback is a virtual address that allows us to remote into the router remotely. Allows us to access the router remotely. So if and it's for only management, it's not to like switch traffic throughout. So if anytime they're like, oh, can you check the router? Can you check the gateway to make sure that there's traffic flowing, or see if there's any errors, or configure something, or whatever. If you just need to get into this gateway, get into this router, most of the time you would utilize the IP address of the loopback interface, not necessarily one of the interfaces that's switching through traffic. This line is going to always be in an upstate and is going to have an internal of a private IP address, or an internal IP address that only we can access, that's in the company. So the router ID is usually like the loopback address. It's just the ID that we set on this router to say, hey, represent this router. And this is the address is going to represent, okay? Not for us to switch traffic. So we put this router ID, we configure it on the router. The router now says, hey, I now know my router ID. I know you configured the area. I'm in area 0. I'm in, you basically setting it up to the router to understand that, hey, you're about to start doing the OSPF algorithm, the OSPF rules. Okay, because up here, went ahead, did some areas, we ensured, we put it together. They know their ABR, ASBR. We put the loop back on, which is the router ID, or just set the router ID, most of the time, loopback and the router ID gets configured at the same time. So that's something to remember. That will be on your exam as far as the router ID, which one would be the router ID, a loopback, a serial. They're going to ask you these questions. So if you understand that loopback and router ID kind of synonymous, you're good to go to answer those questions. All right. So now the router understands, is participating in OSPF. It has a router ID. Now is going to send hello packets to its neighbors to see, hey, are you participating in OSPF2? Do I need to know your information? So it's gonna, seeking each other network. These hello packets are gonna, come together. I think they get sent like every so many seconds or so many milliseconds, something in that sort. But it's a multicast. They're sending it, hey, I want to know what you have going on. That's hello packets, okay? In these packets, they'll come with obviously the information that they're telling each other about. Hey, this is what's configured for me to tell you. And they're going to send it in this hello packet. And then the router is going to read the hello packet and, make what's called an adjacency. Make a neighbor adjacent is kind of what, it's going to be called here. So these neighbors that they're going to form, it depends on the type. These are the different types. So these types, they're in categories. They kind of like how we did ether channel. Remember how one end was, let's say, passive, the other end was active, and then they talk to each other and figure out how to create that link, how to create that, that link. This is kind of the same way with OSPF. One of the neighbors is, going to be configured. The other neighbor is going to be configured. They'll come together and say, hey, are we going to do this in a broadcast, a point to multi-point? What are we doing? Okay. And I have a blog out here that I wrote that I'm gonna send you. That's gonna be in the Trello, so you guys can kind of read more of how they make an adjacency and how they determine if it's going to be a designated router or a backup designated router. This is right here, Alexa DR and a BDR. DR is designated router. BDR is backup designated router, right? Because we're trying to set this algorithm is setting up to where, okay, this is first point, send this data through this link. And if this link go down for any reason, here's a backup link, send it through here, right? So they're forming, they're doing some type of election. We're not going to go too far into the mechanics of the election, but you should definitely read on it so you can understand, okay, they're making this type of network type, right? This is how they're going to choose it. Now they make the network type, the adjacents, they're formed, the adjacencies are formed. They go ahead and start exchanging all this information. This information we call LSA, link state advertisement. It's just saying, hey, this is my routing table, right? And the other one is like, oh, thank you for your routing table. This is my routing table. Then they update their own routing tables with the network and the links that they've learned from the neighbor router, you can say, right? So this OSPF, just really look at it as routers sharing traffic routes with each other, sharing network routes. Okay, well, I know this. Okay, what do you know? You know this. Okay, then they're gonna build this type of topology from their own point of view and with the information they got from their neighbors. And this is how they're gonna say, okay, well, this is the network, and this is how we can better route the traffic based off of the information that you gave me. So that's kind of how this dynamic routing protocol is going to work. Remember, we set up static routes. So the router only knows how to route traffic if we tell it to route traffic. Tell it to say, hey, route 192 traffic to 172 router. We're telling it. But with a dynamic routing protocol like OSPF, you don't have to dictate the routes. You just say, hey, the router knows these routes because you put the interface on, and then you turn on OSPF. You configure it to say, hey, router, you're going to operate in OSPF in this area, and then it's going to create those adjacencies and say, hey, we're going to learn these routes. We're going to learn this network and learn the best path to switch your traffic instead of you telling me every single route to switch your traffic. Okay, it just helps you better with not have to manually put in routes to route every single piece of data that comes your way. And it's just another form of like automation, right? It's just another form of the computer using its intelligence instead of us putting in everything manually. Okay. So yeah, so that's, link state advertisement. I don't think you have to know about that in this exam. I think in the next one, the CCNP, with routing, you would have to learn about link state advertisements a lot, but just know that what LSAs are, and they are link state advertisements that get sent, and it helps the router build a topology of the network from their perspective. That's really all you have to know in a nutshell. Like I said, this PDF and another blog here will definitely
will be number 1 is TSU Team Hub. This is where all our hub information is at. This is where you'll go first, and you can ask questions here, create you a nice card with your name on it, and let us know what you're here, what your goals is, so we can help you accomplish that. Okay? The second board you would come up to is how to get a 6-figure job. This is my exact path on how I was able to break into tech and get a 6-figure tech job. Even when you got that job, or let's just say you are at a comfortable job, it may not be 6 figures, maybe, 90K, 80K, something in that sort, and now you're looking into making 6 figures in your business. You can use this board as well, so we can help you get to that goal with getting 6 figures in your business, okay, by utilizing technology. And the third one here that everyone mostly is at is the CCNA or Net Plus exam notes. All right. These are all the exam notes here. And we have it in our boards that you see where it has start, and you see our network fundamentals, network
available in the Trello. Now we talked about the router, what the routing table looks like. And as you can see here, show IP route, the codes 0 OSPF, okay? And then as you can see, OSPF has learned these routes, right? These networks, so they can route. And it has the O, and then it has the actual IP address, okay? And then these are configurations. Really, with OSPF, is really simple. It can seem like a lot, but it's really simple. It's really just you have to get the concept of how OSPF works. But as far as configurations, you're just going into each router. You are putting in this command, router OSPF, and then you put the number. Number is arbitrary. You always start with 0. This your first time, you start with 0. You want to add a router and create another, OSPF. You can put anyone. You can put 1, 2, 3, any number you want, but you have to start off as 0. So you would come into the router. First thing you're going to say is router OSPF, the number. You're saying router, participate in this routing protocol, and here's our area. Then you say network, right? Once you do that, the router is going to accept it in the command terminal. And then network, you're going to put the keyword network. You're going to put the IP address and the subnet mask, and then you're going to say area 0. Okay. Now, I think I said that backwards. Router OSPF, as I can see here, it doesn't have to be 0. It can be an arbitrary number. Excuse me for that, because this is where you put the area that is going to belong in. So when you put these commands on each router, you have to put this same number. That's what that is. So router, you're telling the router to operate in this dynamic protocol, which is OSPF, and you're putting a number to say operate under this, like ether channel. You got to put it in the same port channel, and it has to be the same port channel on one end, and on the other end, you can't just make it up all different type of numbers. So if you decide to say that it's 10, make sure on all the other routers, your OSP number is 10 as well, okay? And then your network, IP, subnet, area 0. So this command, you have to put the area, start off with 0, then you can, go to others. And you do this for each router, right? Sometimes your network is only 2, 3 interfaces that you only have to add, maybe even 1, right? And then you're verifying by saying show the show command, show IP route, or show IP, or show, I think it's IP route, OSPF, something in that sort. But there are show commands that you can do to ensure that these took. And as you can see here, these are all the commands you're doing. And boom, you configured OSPF, right? Very, very simple. It's just you have to understand the mechanics behind how it's working. These little bits here, single area versus multi-area. Single area, like I said, is just the one area, area 0. Multi-area is having more than one area, more than area 0, area 1, area 2. A wildcard is what you have to put for the network part. I did say subnet mask, but the subnet mask is going to be in the form of a wildcard. Usually it's something as this. I don't want to go too into wildcards because then it's like subnetting. So I have it in the blog on how we get the wildcard. This is usually what I put, 000.3. Version 2 is IPv4, OSPF. Version 3 right here is IPv6, okay? And then the read, that's just the blog. Just read the blog, okay? So let's see. We have this here. This is a blog I'm going to give you guys so you can fully understand it too. And let's do this lab, okay? Let me bring this lab over here. Let's pull up our packet tracer. And let's do a lab. So we got router 2911. Oh, well, I guess I'm gonna do all the same routers. How about that? All the same routers. And then let's do a computer, PC, PC, okay? And then let's go ahead and connect the PC. Oops. Let's connect PC with some good old babies. Let's come in here. We need some modules, okay? So hopefully you guys can see this. I'm sorry. Let's do this one, right? This is the 2-port serial high-speed WAN interface card. Let's go ahead and power baby daddy off here. Oh, I can't zoom in. There we go. Power off, this the power button. Power off. Let's get the module. Come in here, power on. Let's exit. Okay, I think I can. There you go. So you guys can see it a little more better. Okay, let's go into this router, do the same thing. Let's zoom in. Let's open it up. Let's zoom in. Let's power this baby off. Let's get one of these high-speed 2 ports. Interface. Module. Turn it on. Exit. And let's do the same thing with this. Zoom in. Oh, turn it off. Put that module in. Turn it on. Okay. Exit. Now let's get the serial DCE. Let's hook it up to interface 0. Let's hook that up to serial 0. Let's do another DCE. Let's hook that up to 1, of course. And let's hook that up to 1. And then let's do another one. Let's hook that up to 1. And we can hook that up to 0. All right. Okay. Boom. 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 And just for illustration purposes, let's put a cloud to say that this is the internet. Okay. I don't know which cable. Ooh. Oh, it says auto connection. It's not multi. Oh, okay. So I guess I gotta do something like this. Do I want to do gigabit? Yeah, gigabit 0. Okay, cool. Oh, create new link. All right. We're just gonna say that this is the internet service provider. Okay, just again, illustration purposes. Now we must do is go ahead and set up our IPs. I like to write everything out because it just helps me when I'm reading. So let's do R router 0, enter. Router 0 has gigabit 0. I'm shorthanding this because I don't need to write all this, but follow along with me. It has 192.168.1.1. I'm getting these IPs from the lab, guys, in case you're wondering. /24. /24, okay? And then we have serial 0 equals 192.168.12.1. And this is going to be a /30. And then we have serial 1 equals, let's do 192.168.13. Hold on. 1.13.1. And that's going to be a /30 as well. Okay, boom. Done with router 0. Let's do router 1. Enter. Router 1 has, let's say, the loopback. Router 1 needs a loopback. 209.165.225. Ooh, 225 /30. And then let's do serial 0 is 192.168.12.2 /30. And then let's do serial 1, it's 192.168.23.1 /30. All right, that's router 1. Let's do router 2. Router 2 has a interface to the computer. So we're going to do that gigabit 192.168.3.1. That's going to be a /24. And then serial 0 is going to be 192.168.13.2 /30. I hope I'm getting this right. I'm just notating the IPs down from the lab, right? I'm just following the lab, guys. I'm not like making nothing up. So PC 0, let's put 192.168.1.3 /24. And then 192.168.3.3 /24. Ooh, baby. Cancel. I didn't do a slash, I did a dot. Okay, cool. So we're gonna move this over here. Okay, we're gonna move this over here. I guess we can move this right here. Yes, there we go. And then router 2. Okay, look. Put that right here. Put this right here. And then this router 1. Okay, so we know. And this is that. Just so we know. Okay, because we got to know. This is going to be our gigabit. And we can just hover over these little red things and see like, okay, that's S0. That's serial 0. We come over here, that's serial 1. All right. Boom. We should be good to go. Let me just fix that. Now what we have to do is go ahead. In the lab, there's going to be some things where you have to configure message of the day and passwords. You can skip all of that, okay? We just want to get to the OSP configs only, okay? So the first thing we're going to do is set up the IPs on this computer, right? So go into the computer. We're going to click config. We're going to click interface. And oh, that's another thing. I didn't give y'all the default gateway, but we got to add the default gateway in here, which is 192.168.1.1 for PCA. So we're going to go into the interface, fast Ethernet on this end, and it is going to be 192.168.1.3. Okay, it's automatically going to have a /24. So let's go ahead and do the same thing for this PC. Let me put it over here so I can see the IP address. Configs. The gateway is 192.168.3.1. Okay, gateway, default gateway, right? So way out the router. This is the address. Okay, then we're going to do the interface. The IP address on here is 192.168.3.3. It's always going to give you your automatic classful subnet mask. All right, now that that's there, go ahead and configure these two IP addresses on the router, right? So on the router, we're going to do the CLI, and let me see if I can kind of make it to where you guys can see a little bit, hopefully. If it shows. Okay, so you can see down here, we all know what this says. We're gonna go into no. No, we're not gonna set up the router up. So skip all of that. You have to get into enable, EN is what I put. On FT is what I do. And I do IP address. Okay, we kind of already know how to do this, so I don't have to go too hard on guys. You could do SO/0/0, because that's the name of the interface. Oh, whoa, whoa, whoa. Get into the interface first. INTSO/0/0. Enter. Now we're in the interface. Go ahead and add an IP address. So 00 is going to be 192.168.12.1. The subnet mask of 255.255.255.252 is /30, right? Enter. Enter. That's the IP address. Let's go ahead and do a no shut on that IP address. Then on that interface. Then let's go into the interface. S0/0/1. Is that it? Yes, it is. Okay. So now we're in this interface. We're going to do the IP address of, let me see, 192.168.13.1/30. 255.255.255.252. All right. We're going to do a no shut on that, baby. All right, cool. Then we have to go into interface G0/0. Yes, G0/0. We're going to put an IP address of 192.168.1.1. And then we already know our subnet mask is 255.255.255. Enter. Oh, no, sorry. IP address 255.0. You see, boom. And we're gonna do a no shut on that, baby. All right, boom. Now we can exit. Now, those IP addresses are now set up. Let's exit out. We're gonna do one thing at a time. So let's go back. Let's go into router one. Router one. I want to try to get this a little up for you guys, just so you can see. Okay. So the CLI, right? Same thing we did before. No, we don't want to go through the command, the setup, enable, okay? ConFT. All right, so let's configure these here. Maybe I should come over here so I can see my shoes. Okay, so we're in the config T. So let's go into interface. Which one you want to do? We can do G0 because wasn't that to the internet? G0/0. We're gonna do IP address. Let's make it the loop back. Actually, well, yeah, we can make it the loop back. 200.255. And then /30 is what? 255.255.255.252. Oh, it says IP address. Oh man, 1, 2, 3, 4. Bad mask for this. Maybe it should be a /32. Let me see what they have here in this lab. They have it the same, but let's do this. 254 or 253. I don't know which one they want me to use, honestly. Let's see, IP address. It says a bad mask, and this is the mask that they gave me. But let's try. Let's try this. Goodness. Okay, we're gonna skip the 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 this one. Let me move it. We're gonna skip this. This is what we're trying to configure. Because what is this? Let me click on it. Yeah, it's G0/0. Yeah. Let's skip that because that's for illustration purposes anyway. I don't want to get too carried away on configuring that. It is a bad mask, so let's go to exit. Let's do interface serial G/0/0. Let's do IP address, and you gotta learn how to spell address. Let's do, this is this 192.168.12.2, 255.255.255.252. Okay. Let's do a no shut on that baby. And then let's go into interface 0/0/0/1, right? Let's do IP address is 2.68.23.1, 255.255.255.252. All right, no shut on that baby boy. All right, let's just say interface loop back 0. Okay, that's it. Let's do IP address 209.165.200.255.255.255.252. Well, that's up. Exit. All right, so let's exit out of that. All right, so that looks like green. Look, green, green. Why we configured these, why aren't they green? They're not green because I have to configure these first. In order for these to be green, a connection has to be made. So let's go to router 2, right? This is the third router. So we out here doing our thing. So let's do CLI. No, we don't want to go through no configuring. Okay, let's enable. Let's con FT. All right, let's go into the interface. Interface what? Interface G00. Let's do IP address 192.168.3.1. Subnet mask, let's not forget, is 0. All right. Now, if you like, you can say exit, right? Now you can say interface. I do int, interface 0/serial/0/0/0, right? So now I'm in this interface, and then I'm gonna put an IP address of 192.168.13.2, 255.255.255.252/30. Now I don't do exit. I just do interface serial 0/0/1. Enter. Now I'm in that interface. Then I can do IP address, and then I'm going to put the IP address of 192.168.23.2/30, 255.255.255.252. Right. Now what I didn't do is I didn't do a no shut. So let me go into no shut. Let me do that. Let me go to interface 0/0/0, right, and do a no shut. It's a piece of crap. No shut. Okay, and then what? That was interface interface G0/0. No shut. I should have did the no shut. All right, now we are good to go, guys. You see that green, you see that green, you see that green. We have configured our interfaces, our IP addresses on our interfaces. So now they have a connection. All right, cool beans. So now we can configure OSPF. First thing we have to do is configure router ID. Okay, the router ID is going to be the IP address or the name of the router. So let's give 01. Let's give it, as you can see, you see all these change stages to up. These are system logging messages, right? They are here to let you know that things are happening on this system, and these are the logs that we're keeping. And we'll go through system logging. I ain't gonna go. So let's start off. The first thing you do is set OSPF. Turn that baby on and set the router ID. So how do we turn it on? We're already in the config terminal. What's the first one that we had? Router. Router participating. OSPF number. Let's just say 1. Keep it at ease. Wow. Now the router says, oh, okay, cool. Protocol. Let's do router dash ID. We're gonna set the ID is, let's just do one, something simple. Boom, done. Exit. See, you can do that. Do the same thing for all. Just make sure you change the ID name. So for instance, let's go in here. Hopefully you guys see this. I'm sorry if you can't. So what did we say? We said we was gonna go into router OSPF 1, and then router dash ID 2222. Okay, and then do the same thing for this router. Let's exit, be in the config terminal, and do router OSPF 1, and then say router ID. We did 2 last time, we're gonna do 3. Okay, boom. Now we turned on OSPF. We set a router ID, the name of the router. Now we must advertise our network. We say, router, I want you to advertise these networks in this OSPF protocol. Okay, so let's go into this router, right? Let's pop it up in here. Let's pop this open here. All right, so we're in the config terminal already. We got to go into router OSPF 1. Okay, and this is what you want to do with this OSPF 1. We're always going to put the network command and then word network. Okay, what networks do our router have? Do our router knows already that we set 192.168? It's a network, not the interface, not the IP address, but the network. So the network is 192.168 dot, what do we have? We have 12, okay? 12.0. That's the network. And then the subnet mask is 0.0.0 dot 3, 1, 2, 3, 4. Yes, because it's the wild card instead. We're going to put it in the area 0. All right. Another network we have is network 192.168. Let's do it for our gigabit, right? Or connecting to the PC, 192.168.1.0. Okay, so 0 times 0. That's not a /30, it's a /24. So let's do 255. Okay, because that used to be a 0. Now it's a 255. Wildcards was like the opposite. It's an introverted subnet mask. Okay. I think that will be on the exam. Maybe not. We'll go anyway. Keep going. Boom. That's network. And then here's another network: 192.168.13.0, right? And then 0/0/3. Okay. And then area 0. All right. Boom. Hey, router, advertise these networks, and these networks right here, okay, that we already configured. Do the same thing for router 1. So router 1, let's go in here, okay? Let's do, oh, we're already in router OSPF. So all we got to do is the network command. Let's move this over here so we can look at our networks, okay? So network, we're not going to advertise our loopback, that 209, This loopback address, we're not going to advertise it. Okay, we're not going to advertise it. We're just advertising because loopback is for us. That's our management. That's for us as engineers and admins, analysts to come in and, you know, shift through the router. So we're going to do 192.168.12 dot, hold on, 12, where I'm at, dot 2, 0.0.0.3, area 0, okay? Let me just make sure that's right, 168.12. Okay, yeah, because I was looking at something completely different. Another next one. Okay, so look at this. A system message came. I don't know if you can see this, but I'm going to read it. It says OSPF5 adjacent process 1 NBR 11111 on serial 0/0/0 from loading to full loading done. Boom, it made an adjacency. Okay, so it messed me up my thing. So let's do network 192. Let's finish. Now there is a way for you to put a command to where it doesn't mess the system logging messages does not mess you up while you are configuring things. We just didn't set that command. I think it's no system log, no slice log, something like that. But we have a lesson for that called hardening 0/0/0/3. Almost messed up, y'all. Messed me up. All right, cool. Boom. That's done. We only needed 2 network to do that. We can do exit if we want it. And then let's go ahead and exit. And then we have one more. Let's home number 2. Okay, well, the third route, it just starts at 0. Okay, we're already in the ID. So we got to advertise these 3 networks. They are the network. Did I do the network? Hold on. Yes, I did the network. /2/ I didn't do the freaking network. Okay, cool. So I was talking, running my mouth for no reason. Let's come back in here. I made a boo-boo. All right. So what we got to do is come into the config. I have to, because I didn't do the network. I did the actual ID, as you can see, the full freaking IP and not the network IP. And that should be a 0, not a 2, whatever. We're going to fix it. So I'm in the config terminal. Let's go ahead and do router OSPF1, enter, and then let's do no. Let's see if I can run my commands back. I'm gonna push the up button. I'm gonna do a no to this right here. No. Okay, yeah. And then where's my other network? -2, yes. I'm gonna do a no to that as well. Okay. Boom. So now you see the adjacency is down, which is good. So now I'm going to go back up, and instead of doing a no, actually I'm going to change this from 2 to 0. Y'all see what I did wrong? If you didn't, you might want to rewatch this. Rewind. Okay. And then I'm going to go back up, and I'm going to say network 12. I should do, instead of network 12, I should do network 23. So let's do 23. Boom, there we go. All right, sorry, it was a message. Okay, cool. So you see, I went ahead and fixed that. So you did whatever. Let's go into router 2. Woo. All right, so router 2, let's advertise our networks because baby, I need to stop talking. 192.168.3.0. Okay. And then 2 0/0/0/3 area 0 network 192.168.13.0/0/0/3 area 0 network 192. 168.3.0. Yeah, 0, 0, 3. Is that 4? Yeah. Area 0. All right. Whew. So they have made their adjacencies. Oh my gosh, that was crazy. So let's go to router 0. Let's go back. Okay, let's exit out of config terminal. And let's do some show commands. Let's do show IP route OSPF. Okay, so OSPF know these two routes, right? 1923. Learn these routes. Okay, yeah. We can do yeah, show IP route. That's kind of good. Maybe show IP neighbor. Show IP OSPF and EIGHEOR. I can't spell, guys. So boom. Okay, there we go. So the neighbor is 222 and 333. That's exactly what we want. Okay, let's go ahead and copy that command. Exit. And we could do the same thing here. As we can see, they've been creating adjacencies any freaking way. So let's do show IP OSPF. I didn't spell that right. OSPF. We're going to do neighbor. Enter. As you can see, these are the neighbors. So we have it all configured. Let's test to see if PC0 can talk to PC1. So we're obviously going to come into here. We're going to do desktop, do the command prompt, ping, right? We always want to do a ping here. And the ping is, so we're on this PC0. So let's turn it, we're going to ping PC1. PC's one IP address is 192.168.3.3. Okay, you see how we're pinging this computer? Let's see. Baby, it's not, it says it timed out. Oh, but then it did go through. Okay. So since it timed out that one time, that's just an ARP address resolution protocol. It just used one of the pings to try to send and make a connection to find this PC1. Okay, but as you can see, we can run it again if you want, so we can get all our pings, all 4. So that is how you configure OSPF, and that is how you verify it. So please go over this lab here